Hello, I'm Stefania Del Prete. We're going to check the happiness report dataset data analysis in Python. So first of all, our happiness report dataset is connected with Sustainable Development Goal 3 about health, and it contains different columns from the country name, the happiness rank, and the happiness score, and then different categories such as economy, family, health, life expectancy, freedom, that are metrics, and where the metrics that we're going to see is to what extent each of these category contribute to the calculation of the happiness score. So the contribution to arrive to this happiness score. Here are some more details. And why do you choose? We choose to use Python. So Python has a limitation in terms of you have to know a little bit of Python coding in order to customize completely. And in particular, if we want to use notebook in Python, are very, very good because we can see both some documentation, some written words, coding, and execution of this coding. So it's very good for displaying the whole process. But if we want to put everything in production, we need some extra steps. Also, for a very, very interactive dashboard, we need extra steps to really do that. Is not internally in what is called the standard library inside Python. And something very good if you use Google Colab is that we're going to use the resources of Google. There are already some pre-installed libraries such as NumPy, Pandas to manipulate the data, Matplotlib and Seaborn for the graphics. But in case you want to download everything open source in your computer, you can do that. Jupyter notebooks are just the tool, the notebooks itself. If you download the Anaconda distribution, then what we're going to have is also all the different packages. We can see here that is our NumPy and Pandas, or for visualization, Matplotlib, Seaborn. These are the four that we are going to use. Jupyter are the notebook itself that we're going to use. So just in case you want to do everything local and open sourced, you can use it directly from here. In our case, we're going to use Google Colab, so for everyone, you don't have anything to download and install in your computer. So for these cases, you can download the Jupyter Notebook and add it to your own drive and then open it. In this case, if you open it, you will have something, probably something like that. You can just click it and it's going to open. Otherwise, another thing that you can do is to go to, you can just search Colab Research and click Upload. If you click Upload and then Browse, you can browse the Jupyter Notebook you downloaded. When you upload it, you can have it in your computer. In both cases, so if you upload it, will be fine. You have to make sure where it is. If in doubt, you can do File, Locate in Drive, just to be sure of where is it. My suggestion is also to customize the name, so you or put, for example, a date at the beginning, so you will know where I'm going to start. For our purposes, to start where you are, we can also do an edit and then clear all outputs. So we will see one output at a time together. We'll see here there is no the output. So our first step is to gather the data and the ideas. So first of all, based on what we mentioned and what we explore of the data set, we can start to have some ideas that, of course, iteratively can be implemented during the exploration, sometimes also during the data visualization phase, interpreting the data. So it's something that can evolve, but it's good to have a starting point. For our particular cases, we want to see correlation between the different contribution of the happiness score, and also see some distribution, some histograms of them. First of all, we have to import the data. And as you see here, a nice thing is that we can have a table of content based on the titles that we're going to add it in the documentation cells, in the code cells. Just a reminder, we can add the code cells just clicking here, plus code, or plus text in here. If you double click, we're going to see what's inside the text cell. And then in my computer, you can do Control Enter, or the caps letter, the letter for the uppercase, and then Enter. So in this case, you can see you can run that cell. You can also do some use some help if you want to check some frequent questions and release note. Also in tools, in particular in tools, you can check the keyboard's shortcut. So that could be a bit different based on your computer. If you have usually in Unix or Mac, you can have command instead of control, and you can also change some of them, but it's not our main purposes. You can see here all the section about run the cells. Okay, so you can use Alt Enter if you want to insert another cell just after that, or Shift, the command that I mentioned for the upper letter, Shift Enter to run the selected and go to the next. Okay, so we see here that we have our text cell and our code cell. And in here, you can notice table of content. So if you get lost, we can go back here on our different steps, our 4 steps. Let's start from the beginning, gather the data. To do that, we still need our first library, 2 libraries, in particular pandas. You can also check here each of them. Just a reminder, libraries are a huge amount of code that are written by someone else that we want to use it. To use it, we have to install it in our computer. In this case, the machine, the virtual machine behind our notebook in Google Colab has already everything installed. We notice here, connect, that as soon as we run the first one, so our Shift and Enter, this is connecting. And this is connecting to this virtual machine. When it is going to be green connected, this also shows our space and memory that we have available. You can see here a 1. It means that this is the first cell that we executed. So we import in the 2 libraries. And then for gathering the data, we have 3 different ways to do that. Here is the simple one. I just wanted to let you know that when you see some greens, you can notice here for this character to have some comments. The comments are not going to be executed, but just for our reference. So in this way, we put the URL, the path where we find our CSV dataset. And then with this, we're going to read and save it as a particular format called pandas data frame. That is the format that we're going to use in pandas. You can see every time that we recall it PD, it's such a shortcut to use the pandas library. And we're going to read it. Another way is to drag and drop in these temporary folders. So you can see here is not connected to your drive. You can see here is a Mount Drive, your own Google Drive. And you can drag and drop in here temporarily. Temporarily means that when you close it and reopen, you have to do that again. The last and sometimes more complicated is to actually connect with your drive And then what we want to do is to see exactly what are the data, where are your folder. So I show you for this one, you have to eventually connect to your own drive. You will see a folder called drive. And then from here, you have to copy path and save it in this read csv command. If you have problem, let me know. This is the easy way. If it's something that is already on the web, you can directly do that and is on your own computer. So we're going to see some command to just show you what you can do. If you don't know anything about Python, you can see and copy and paste these commands. Just know what they mean. So df is our saved dataset. So every time that we recall it, it means to recall the dataset itself. .head, it means show me the first 5 lines. .info, it means show me all the statistics for the numerical columns. Show me all the types of all the columns. That I was already on the describe mode. So .info, we can see all the type. We have integers. When we see object, usually is a string, so alphabetic, like the country name, and then all the others are float, that means decimal point, and at the end another words, let's say alphanumeric. .columns, it shows us all the name of the columns. That could be helpful if we want to change it, or if you wanted to recall it for a data visualization. Then we're going to do phase 2, data exploration. And here we can really do a lot of things. And let's check, for example, some of the commands and some of the manipulation. First of all, what we want to do is to change the name of columns in something that is more readable and easy to copy and paste. For example, an easy way to do that is to copy the whole list and associate the columns with change a little bit the names. Take care that has to be always the same amount of columns. This one we are not going to change it because we want to drop it. And using df.drop with the argument columns equal, we call it a list, this one between the square bracket, we're going to drop all these columns. So let's run these cells. And you see here that all the different columns are be updated with the names that we want. And some of them are going to be dropped. With shape, we saw that we have 10 columns and 147 rows. The info again, similarly, but without the columns drops and with the name updated. And our data frame describe, on describe, we can see all the numerical values. We have the count, the mean, the standard deviation, and the different quartile of our distribution. So it's very, very interesting. With one command, we can see all of them. With a simple command, we can also round up to only 2 decimal points. And with our group by, this is just for visualization, so it temporarily is not going to change our data sets. But just to see, we can group by the continent. So we can check all these values by continent, but we need a reduction function, something that from many numbers just give us 1. And we want to do that only when we have numerical values. We choose the mean, the average. And we have here a compact visualization of the different columns, numerical columns, and our continent. And here is the medium, the mean of all our values. So we can instantly see, for example, that in Africa, social support has less contribution, for example, that more contribution than the values about life expectancy. That is quite the opposite, for example, for South America. Similarly, not quite the opposite. We have 1.5 and 0.5. So similarly, we have almost the same times 3 for these two contribution for these two continents. So it's interesting that already with the numbers we can check it. Then the third part is our data visualization. Of course, just to mention, for data exploration, we can continue to do this group by for different variables, different also different reduction function, for example, the median instead of the mean, etc., etc. We can continue to manipulate some columns. For the purpose, we keep it short just for a presentation of what we can do. So we move to the data visualization, and it's good to have something in mind. For example, we have in mind from the beginning that we want to see some correlation. In here, we can see that we need to import the other two libraries that are the data visualization libraries. And then the nice thing is that once we know how to do this kind of visualization, we can just change the name of the column of the variable used, and we easily generate a new graph. So without clicking here and there, it's just the code itself that needs to be updated and eventually copy and paste in another cell. We use PLT as shortcut for matplotlib, this library, and SNS as shortcut for Seaborn. So PLT title, we're going to add a title to our graph, and then we choose to use Seaborn for our graph. Boxplot is going to generate the box plot of the distribution of the perception of corruption and divided for each continent, where we pick the data from our data frame. The F is always our data set that we imported. So we show this different graph. We already see a big difference in the distribution, in particular in Oceania compared to South America, and actually compared to all the others. So interesting to see. This is actually a box plot. These are the outliers. That means that are a little bit away from the central distribution. This row in the middle is the median. And here we have the different cut for the 20%, 50%, 70% of our distribution for each continent. We remind our columns to remember eventually if we want to choose our different columns. Remember that we saved also the name of the original columns, just in case we need to going back to them. This is something that sometimes is useful to save the original version and then a modified version. And let's create another one. For the scatter plot is .scatter plot. We need two variables to correlate with. We choose for the capital and the corruption. We add the title, and again we execute the cell. Here we can see there's not a huge correlation, but it's still going up together. We see that the maximum values for both of them are going quite in the same direction. But in the middle of it, there is not a very strong correlation. We can also do a selection. So, for example, we want to check this cut of our LGD from 50. And so just to check what is this one, for example. A good thing about using code is that you can really pinpoint directly the values that we want to check for this value, LDG capital, less than 0.5. We put it as a selection all this selection we have to be imposed to our data frame. That's why there is a repetition. We choose this column and we choose the conditional. And we see is Venezuela. Venezuela has a very low contribution for the happiness score is due to the GDP capita. We can start think about if you think about also the recent events in Venezuela is quite eventually could be had a huge impact on the country itself. So again, you use PLT for our title, and then we use another scatter plot. Now we're adding something more, U for continent. So we have a division of colors in this case based on the continent. We can see that we already checked, in this case, we have the correlation between social support and life expectancy. And you can see that here, for sure, we didn't, without having this sort of selection, we know that is a country in Asia. Eventually, you can do, I suggest to do a similar selection to see which country it is. So it will be social support that has to be less than 0.2, for example. We can do a selection just for a few countries. And in this case, we put a list of the countries that we want, just add this particular selection. And we can do eventually the same correlation, social support and life expectancy. This time with the continent as style of the point, this different point. For the hue, you use the country. This particular command is to move our legend that is not going to be on the top of the rest of the graph. So just to let you understand better, if we take out these, you can see that the legend was above. So if we, if we add it back, we have it outside the Canva. So we selected only few countries. Maybe we needed this particular country to be seen as correlation. This is also for educational purposes to show you the different hue and style properties. And we can see, for example, that in Oceania is the big dot, the X is for Europe, and for example, we can see there is Spain in here, Italy, and Estonia. And we can see there is two very close values for these two countries. You can check our Instagram with his plot. So the histogram for generosity, we can see a nice distribution around 0.12 probably. We can customize the beans, that is very important. The beans is the number of interval shows in the graph. So if this one was lower, for example, 10, we can see there are bigger intervals because it's less in number. You can see that based on that, we can check different nuance of the distribution. So we can you can play with it in order to know if there is some hidden trends. Of course, take in consideration that we have around a little bit more than 100 countries in these data sets, and so the number has to be considerate of that. So here already 20 is a little high, considering that it could be around 5 or 6 for each of these intervals. So you can think about this proportion as well. We did the same for other two. In particular, we add also the hue for continent. And this we see this a little bit of overlap. So we need to know if we need it or not. If it makes the things less clear, it means that it's not the representation that we want. Perhaps something like that could be more interesting to showcase the difference between the continent. And we can also do the same for, again, for checking just two of our continent. And if you notice in here, I go just a little bit up, we put the selected countries in another variable, and then we use it inside this selection. So the data frame was already selected by country, is in the selected countries that are these. For all the others, we use directly the whole dataset. For this last graph, we did a selection in here as well. So from our old dataset, we did this selection. The selection is that the continent has to be, is in Europe or Asia. And we use generosity as the variable for our distribution to be checked, and then the hue for continent. Okay. The last step is to use our mind to interpret the data. We already mentioned something about Venezuela, other countries, continent, the differences, and see what are the more relevant for the message that we want to convey. Just going back to the same question in here. And once we did it, we can see if we're satisfied, if we need supplementary resources, or if you have already enough data to showcase some insights that could be helpful to support some decision making, reporting, or in general for our knowledge management. Okay. I know that Python could need a little bit more learning. The learning curve could be a little bit more more high than more quick than others, but quick in the speed of raising difficulty. But if you have enough time to learn and will to work on different example, I'm sure you can do that. There is some more resources also in the other decal slide. So be persistent, eventually show me your work, and you can repeat it for another data set or for another year of the happiness report. Thank you, and enjoy studying and practicing.